Okay, I'm going to do a walkthrough on how to find the coordinate of a point on a segment when we're given a ratio and we have to find that point within that given ratio. So the ratio we're going to have is that from point G to point L is 4 and L to M is 3. So 4-3 ratio. So I have that written over to the side. We have the coordinates of G and M already given. We have -2, 1 for G and 5, 3 for M. And our goal is to find the coordinates for L. L we're not given, so the first thing we're going to do is we're just going to call it some generic X and Y. And we're going to use that in our calculations. So the first thing that we're going to have to do is we're going to set up a fraction GL over LM. These are segment lengths, and it's going to have the proportionality of 4-3. And we're going to create another proportionality here involving just the x values first. So when we look at our diagram, we have to ask ourselves which is going to have the biggest x value, and then we're going to subtract the smaller x value from that. So just like you do when you first learn to subtract, you take a big number and you subtract a small number from it. And so whatever is furthest to the right is always the biggest, because we start at 0 at the origin here and we move here towards positive infinity. So looking right is always the bigger of the x values. So we look at this x, we don't know what it is. We look at this x, it's -2. Whatever this x is, it's bigger than -2. And if you look at the diagram, if you can believe the diagram, this is on the right-hand side of the y-axis, so these should all be positive numbers. So we have a positive number, we're going to subtract a negative number from it. When you set this up, you have you're subtracting a negative number, so you need to keep track of all these negatives here. You're going to cause a sign change here. This is going to be x plus 2 when you simplify that. Now looking at the segment LM, we again want to determine which one's the bigger x value. It's going to be 5 this time. It's furthest to the right, so we're going to do 5 minus x. And then we want to simplify this, and we're looking at just this as our equal proportions that we're solving for x. And so you can use whatever your favorite method is for equal proportions. I'm going to cross multiply here. So I'm going to have 4 times x minus 5. And we need to use parentheses here because this is going to be distributive property. And this is going to equal 3 times x plus 2. That's that sign change that I was talking about. And so we're just doing distributive property here. 4 times 5 is 20. Minus 4 times x is 4x. And 3 times x is 3x. 3 times 2 is 6. And so now we're just going to use our algebra skills here and collect x terms on one side and the constant terms on the other. So I'm going to add 4x to both sides here, and when I add my columns I get 7x plus 6 here. Over on this side I'm going to have 20 plus 0, so we're just going to write 20 here. I'm going to subtract 6 on both sides here. So I'm going to end up with 14 equals 7x. And now I'm going to divide both sides by 7, and that's going to give us a very nice value. The x value for point L that we're looking for is going to be 2. If we look at our diagram, that looks really close to where we are on the diagram. And my diagram isn't exactly to scale, so you can't completely believe it, but it looks really close, and that can give us some confidence that we're on the right path. Now, we want to do this same kind of calculation again, only this time written in regard to the y values. So I'm going to set up the GL over LM equals 4/3, and then I'm going to set up a new ratio, and I'm using the y values this time. So I'm going to do that over here. Okay. Okay, I'm looking at y values this time. Again, I'm starting with the GL segment, and I want the biggest y value. Now, this time we are looking for the one that is towards the top. We're counting from 0 up to positive infinity, so the one that is the tallest value, counting up from the x, is going to be the biggest y value. So when we look at this, we have this y is taller than this y value, so we're going to have y minus 1. Y is the L value here that we don't know, and then 1 is the y value on point G that we do know. And then we're going to look at L and M. Which one has the tallest y value here? Well, it's going to be M because this thing is going uphill here. So we are looking at 3, and we're going to subtract this y value here. So we have this setup. So this y minus this one, and then this 3 minus this y. And we're looking at this proportionality, and we're going to do the exact same process that we did over here and see what kind of a y value this solves out to be. So I'm cross multiplying again, so I'm going to have 4 times 3 minus y, using parentheses again, 3 times y minus 1. And then I'm going to do distributive property here and here. 4 times 3 is 12. 4 times y is 4y. 3 times y is 3y. 3 times 1 is 3. Alright, again, we are going to collect y terms on one side, the constant terms on the other. So I'm going to add 4y to both sides here. That's going to leave me 12 on this side. I'm going to have 7y minus 3. And then I'm going to add 3 to both sides. I'm going to end up with 15 equals 7y. And this number is not going to be quite as nice as the x value. We're going to take 15 and divide by 7. That is not a reducible fraction. You could come up with a decimal equivalent here if you wanted to, if you like decimals better. There's really no need for this because we are just trying to find x and y that are the valuation for this missing L term right here. We want these coordinates, and we are simply asked for an x and a y. So we're looking for a point. We're looking for some x and y as an ordered pair. And so the answer for that is going to be the 2 and the 15/7. And this is our answer. This is the final thing that we're looking for to answer the question. And that question was, what are the coordinates of point L? Hopefully this has been helpful, and there are other ways that you can approach these types of problems. This is one particular method. If you find another one that works better for you, go ahead and use it. If this one works better for you, go ahead and use this. Cheerful Calculations.